Hello. In this chapter of the alternating current, we will study the following topics. That is the alternating EMF and the current, average value of the alternating EMF, RMS effective or the virtual value of the alternating EMF and current, AC circuit with resistor, inductor and capacitor, series LCR circuit, resonance and the Q factor, the relationship between the frequency versus the inductive reactance, frequency versus capacitive reactance, power in LCR circuits, LC oscillations, transformer, and AC generator. Now we will start with alternating EMF and current. So, what is a alternating EMF? Alternating EMF is a EMF whose magnitude changes continuously and the direction changes periodically. What I mean to say that it is a representation of the alternating EMF. Now see, the magnitude at t equals to 0 is 0. At t equals to t by 4, the magnitude is maximum. At half cycle, it again 0, and at 3/4 of the cycle, the magnitude is again maximum but in opposite direction, and at the t at one cycle again the magnitude is 0. In this portion the charge flows in one direction, and in this portion the charge flows in other direction. But the magnitude of the charge which is flowing through this is different at different points. At this point the charge is minimum. As we are going up, the magnitude of the charge flowing in this direction towards the right increases, and then the magnitude, that is the amount of charge flowing towards the right direction, decreases, and at this point it becomes 0. Now again the amount of charge increases, but the direction of the flow of charge is reversed. It is the AC. So what is the AC? Whose magnitude changes continuously and direction changes periodically. If in place of EMF we use current, then it is called alternating current. Difference is of the word. It is a representation of the alternating current. This is an instantaneous value. It is a peak value, and this is the angular frequency, which is equal to 2 pi upon t, or equals to 2 pi into n. T is a time at a given instant. This green color represents the alternating current. This green color is the current. And current is also represented in this way. Now, it is also the representation of the alternating current and voltage. The difference is of the equation. Here it is used cos omega t. In place of sine, we are using cos whenever we start from a maximum value. From the extreme positions, then we are using the equation cos omega t. When we start from the mean positions, we are using the sin omega t. Now the average value of the alternating EMF. Average value of the alternating EMF. Here I am first taking a current. So average value of the alternating current over a half cycle is that steady current which will send the same amount of charge through a circuit in the time of half cycle as by the given alternating current through the same circuit in the same time. Here the time is of half cycle, because for the complete cycle the average value is 0. For the positive half, the charge is flowing in this direction. For the negative half, it is flowing in opposite direction. So the net amount of the charge is 0. So whenever we are talking about the mean value, we always talk of the half cycle, any half of the time. Okay, now let us look at the derivation. As you know, current is the rate of flow of charge. I is equal to dq upon dt. It means dq is equal to I into dt. As dq is equal to I into dt, now you know very well that I is equal to I naught sine omega t. So in place of I naught sine omega t. So dq is equal to I naught sine omega t into dt. Now total charge is obtained by integrating the dq for the half cycle. Now in place of dq we put I naught sine omega t. You know very well that I naught is a constant and the integration of the sine omega t is minus cos omega t upon omega, right? And this can be written as minus I naught upon, in place of omega, 2 pi upon t. It is cos, in place of omega, 2 pi upon t. Limits are from 0 to t by 2. Now first put in place of this t by 2 and it will give you minus I naught t upon 2 pi cos 2 pi upon t into t by 2 minus cos 0. This cancel out and it is cos pi. Value of the cos pi is minus 1 and value of cos 0 is also minus 1. 1 becomes 2, minus minus becomes plus, and this equation is equal to I naught t upon 2 pi. It is equal to I naught t upon 2 pi. This one 2 to 2 cancel and it is I naught t upon pi. Okay. Now take it as a equation number 1. Now according to the definition, it is a that steady value which will send the same amount of charge. Now suppose I am saying that I mean value of the current will send the same amount of the charge in the time t by 2. Now compare the equation number 1 and 2. So I naught t upon pi equals to I m t upon 2. Cancel out and I m is equal to 2 upon pi into I naught, which is equal to 0.637 times of I. Okay, clear? This expression is clear now? So this is the value, that is I mean value or the average value is 0.637 times of I. Similarly for the voltage, in place of current we use the word voltage and rest of the definition is same. Wherever the word is current we are using the voltage, right? And same here is the derivation. You know I is equal to dq by dt, so dq is equal to I into dt. In place of I we are using the E upon R, and in place of E naught sine omega t into dt. Now integrating it, rest of the is same. It is the equation number 1. When it is compared with the second equation we are getting the same expression. Thank you and have a nice day.